Okay, now, hi everyone. Now I continue on the lesson. So, um, here we have just lesson topic 8 variation, and I'm going to continue on it. So, we are going to do two, just one question with two different ways, and so I will show you two different ways. So, I'm just using just easy X and Y, and I don't go to like other complicated questions because in here right now I want you to just understand the way that I'm doing it. Okay, see, so you read the question first. It says if y varies directly as x and x is 6 and when y is 18, so what is y when x is 5? See, it's exactly like what I talked about in the first video. So it's like I have situation number one, and I have situation number two. One of them is missing in these four things, so one of them is missing. I want to find it. I need to know varies directly or indirectly. Okay, so y varies directly as x, so means y is kx. Okay, one method is, okay, you write the equation, use k and write the equation. So first you start from expression. This is that's expression here, and that's just equation. So that's equation here. You write, then substitute the first situation to find k. Okay, remember k is constant, that doesn't change. Okay, so when I use k for the first situation, I can use k for the second situation as well. Okay, so it's 18 equal k multiple 6, therefore k is 3. Okay, so now y is k multiple x, which is 3 multiple 5, which is 15. Okay, so I have the first situation, I use the first situation to find k, and then I use my information to find what is missing for the second situation. Okay, so put back k and create the formula. Okay, the formula is y equal 3x. That's the formula. Okay, so and then I can substitute for situation 2 to determine what is the unknown value. Okay, I have another method. Another method is very useful as well. So if you just be patient and just see what I'm doing, then you can use this for a future example that you have more variables. We have more variables. For example, we have x and y, and we have combined variation. One of them directly variation, one of them indirectly variation, and then we combine them. Okay, so you can use this method. Okay, see, I have y alpha x expression. Okay, so y is kx, equation. I use k to write the equation. Now solve for k. Always when you solve for k, it gives you idea how to write two situation equation. Y over x. Okay, k is constant. So k is y1 over x1 equal y2 over x2. Okay, so 18 over 6 is how many? So, or maybe I use question mark over 5, and that question mark is y2. Okay, so maybe I just use y2. So y2 or y for the second situation. Okay, so y2 is 5 multiple 18 divided by 6, which is 15. Okay, yes, that's the answer. Okay, so I create the equation. I did. I use constant of proportionality. Now I solve for k and then create a new equation. So that's here using k. Okay, so k is useful here for me, and k is constant, k doesn't change. and then I substitute just to find the answer, and I did. Okay, two methods, so you go by any of these methods. Now we are going to do more complicated question. Okay, distance d of an object falls under the influence of gravity. Okay, so is proportional, means direct, because it said proportional to the square of t. Read the question carefully. Square of t. Okay, so d alpha t squared. Read the question carefully. I didn't say t, no, a square of t. Okay, so d is kt2. If the object falls this is situation 1. How far means what is d if the time is this. And remember, both of them, so one of them meter second and the other also meter second. Okay, so pay attention to the unit. Maybe one of them might say second, one of them might say minute, so you have to convert. In this case, no. Okay, so I read the question, I understand, so what's going on. Okay, so here, solve for k. Always solve for k. It gives you the two situation formula. Okay, so k is dt squared, d divided by t squared. Okay, so d1 t1 squared is d2 t2 squared. Okay, perfect. Always when you have the question like variation, if you solve for k, it gives you idea how to do the equation for two situations. Of course, when I say I have two things and direct variation, indirect variation is easy because you go to the formula page and you write it. But if I have more variables, it will be confusing. So I always have to solve for k, because k is constant, then I can make the formula here. This is what I want. Okay, so now, what is distance? Okay, so 64 meter to a squared equal d2 divided by 6 squared, and I can find d2. So 64 multiple 36 divided by 4, which is 64 multiple 9, I think, and that's 64 multiple 9, so 576. Yeah, okay, so it is 576 meter. Okay, so how far is 576 meter? And don't forget, you have to write a sentence. Okay, the conclusion is homework. Okay, so here, that's a very good question. What happened for distance if time is double? Okay, I want to show you. It's not always distance is doubled, no, because here is t squared. Okay, so d is kt squared. Okay, so d1 is kt1 squared and t2 is 2t1. Okay, so d2 is kt2 squared, which is k2t1 squared, which is k4t1 squared. So if time is doubled, distance is multiplied by 4 greater. Okay, so it's not always, yes, of course both of them increase because it's directly, but not the same as each other. So it's not always when I say both of them increase, okay, I double one of them, the other double. No, because here I have a squared. Okay, so it depends what you have. Here, when time is double, distance is multiplied by 4. Okay? Greater 4 times. Good. That's a very good question. So pressure is inversely proportional to volume. Okay, pressure P inversely, be careful, proportional to volume. So P expression P alpha 1 over V. Now I want you to write equation P K over V. PV is K when I solve for K. This is always like that. So now, if the pressure double, volume is what? Okay, so P1 V1 is K. Pressure double. P2 is 2P1. I want to see what happened to V2. Okay, so P2 V2 is K. Therefore, V2 is, because I'm looking for V2 in terms of V1, so I do V2 K over P2, which is K over 2P1. Okay, what is K over P1 is, K over P1 is V1. So V1 divided by 2. Okay, pressure double, pressure is doubled, V is cut in half. Why? Because in E is inversely. Okay, and the formula is just PV equal K. There is no squared or something else. Okay, so you can have different. So if volume is reduced by factor 4, if volume is divided by 4, okay, so I do mathematically. So PV is K. Therefore, P1 V1 is K, and volume. So volume 2 is volume 1 divided by 4. What happened to P? Pressure. So pressure 2 V2 is K. Therefore, P2 is K over V2, which is K V1 over 4, which is K divided by V1 over 4, which is K multiplied by 4 over V1. Okay, what is K over V1? P1, yes, P1 divided, so sorry, P1 multiplied 4. Okay, reduced by, so when V is divided by 4, P is multiplied by 4. Yes, I can see. P2 is 4P1. For a certain gas pressure that is 1.5 atmosphere, when volume is 6 liter, find the volume when pressure is 3 atmosphere. See, atmosphere, liter, so I don't need to do any conversion for units. Okay, so PV is K. So P1 V1 is P2 V2, and both of them are K. Okay, what is P1? 1.5, 6. What if I have 3? I'm looking for, find the volume. Yes, so I do this. 3 multiple, it doesn't matter, but here as I have the order like that. So 3 volume, find the volume. Yes, what is V2? Okay, so V2 is 1.5 multiple 6 divided by this. So I have 9 divided by this, so it's this. Okay, 3. So that's the volume. Look at this. Pressure double. Okay, volume divided by 2. Okay, so this is 6 liter. Okay, sorry, 3 liter. Okay, so that's the answer here. Okay, so yeah. How about this question? Any two bodies attract each other with a force that is, okay, so this part is extra information. Okay, so I don't say extra, of course you need it for the question, but you don't need to use it in the solving. Okay, force, so I just highlight that force inversely proportional to a square distance between the center of the mass. Okay, so F alpha 1 over d squared. Force inversely proportional, so because I hear proportional I do this, because I hear inversely I do 1 over, because I hear a square I do d squared there. Okay, perfect. So F is kd squared divided by d squared. Okay, how much will a satellite whose weight on Earth is this weight at the altitude of this above the surface of the Earth? The surface of the Earth is this from the center. Okay, so let's say, for example, the satellite is here. For example, okay, so this is the satellite. Okay, how much is from here to here? So from here to here is 250 meter, right? Oh, sorry, kilometer. 250 kilometer. Okay, what is the, so from just here to here, here to here is 6372 kilometer. Okay, so the satellite on the Earth has this weight, means the satellite, so for example is so a weight, okay, so F is this Newton, right? So F is this Newton when the distance is this. Now I want to know what is F when the distance is this, everything. Okay, so what is K? K is FD squared. Remember, when you always find K, you can find the two situation formula. Okay, okay, perfect. So F1 D1 squared is F2 D2 squared. Okay, so F1 is 675. 675 multiple 6372, yes, squared. And remember, all of them kilometer, kilometer, Newton, so perfect, good. Equal F2, I'm looking for multiple 6372 plus 250. And the bar you have top of 0 beside 5 in 250 is because of significant digits, so we can count it. Okay, so that's because of that. Okay, so now you want to find the answer here. Okay, so remember, oh, s squared. Okay, so now F2, find F2. Okay, so F2 is 675 times 6372 squared. I always tell you, so just use all the numbers until the last part the same. Okay, so you don't round and round and round in the middle. So 675 multiple 6372 squared divided by bracket 6372 plus 250, close the bracket, squared, equal. And this is going to be 624.99559. Okay, so that's the answer. And here, look at this. When we use this, means 3 significant digit. Okay, so I have, okay, so I can just round to three significant digits. Okay, of course, yes, I know here is addition, so here is addition, so I just round to because I have to count zero, so I just round to 0 decimal place, and when I do that, then I have, when overall I have, see, I have 0 decimal place, I have 0 decimal place, I round to, um, so let me see, I round to 0 decimal place, but when I do this, because I have to consider zero so as important one, so then I have four significant digit. Okay, so I have four significant digit, but this is three significant digit, this is four significant digit, so I need to round to three significant digits. So I go here, I underline that, I check that, it is almost 625 Newton. Okay, so when it is on the earth, I have to consider just the distance until the center of the earth. But when it's above, so 250 kilometers, then I have to add that. Okay, and then I can solve. So then I have to write. I have to write the just conclusion sentence. Don't forget that. Okay, you have to do that. So conclusion sentence, conclusion homework. Okay, so combined variation. Now it can be a little more complicated, but if you know what to do, whatever question I give you, it's easy. So just I want you to just pay attention here, watch the video, so maybe you can pause it, do on your own, and then check. Force between two electronically charged particles with charges Q1 and Q2 varies directly as the product of the two charges. Okay, force varies, see, force varies directly as product of this. So F alpha Q1 Q2. Write the equation. Okay, so F is K alpha Q1 Q2. That's it. Okay, sorry. K Q1 Q2. K Q1 Q2. Okay, I use the K, so just that's it. Okay. So here, express an equation for the fact that y varies. Okay, this is very important question because it shows you what to do when you have several variables. Okay, y varies directly as x. Okay, so y alpha x. Y varies inversely as z. Y varies inversely as z. When you see y and y, when you see this and this, then you can combine them. Y alpha x over z. One of them top because it's top, one of them bottom because it's bottom. And then instead of I go with two equations because that's hard, y is changing related to both of them. Okay, so now I can say y is kx over z. So I don't need to have 2k. 1k for the first one, 1k for the bottom. No, we can combine them. And how do I combine? When I see the same thing, when I see alpha, and then I combine them. So if I don't see the same thing, I have to make them the same. Okay? So here, express an equation for the fact that S varies directly as the square of t, inversely as cube of v. Okay, S varies directly. S varies. See, I hear. S varies directly a square of t squared. S varies inversely cube of v. I see S, I see alpha. Now I combine them. S alpha T2 over V cubed. Okay? Good job. And now, maybe, let me see here. Perfect. Maybe here, and so I can make it easy for you, just as a practice, write the equation for two situations. Okay, so here I can do it here. See, if I tell you, okay, if I tell you, so I have two situations and I want you to find one of them is unknown for me and I want you to find it. How do you find it? Okay, solve for k. What happened when you solve for k? Okay, so yz is kx. Therefore, k is yz over x. Oh, perfect. So now, y1 z1 over x1 equal y2 z2 over x2. See? But when I have just two and I say direct, it's easy for me to find the formula. Okay, so when I just have two and it's direct, so look at here. I can go to the formula page. Look at this. And I can memorize it. See, I say direct and it's just two, so it's this case, okay, the beginning. So, sorry, the yellow one, okay. At the beginning, when you write the equation, you don't have any fraction. You don't have any denominator. You can just remember this. But when you write two situation, you have fraction. Here, when you write it inverse, you have fraction divided, but when you write the two situation, there is no. Here you can handle when you have two variables and you have direct and indirect. Yes, I know how to write the equation, but how about if I have more variables? How can I write it? Okay, so my recommendation is solve for k. When you solve for k, then you know, okay, so my handwriting is not good, so this is z. Okay, then you know how to write two equation, two situation for two situation, because k is constant, so you can do it. How about here? Okay, so look at this. S is kt2v cube. Okay, sv cube is kt2 and k is sv cubed over t2. Yes. No, k is not changing. Now write two situation. S1 V1 this, T1 squared is S2 V2 this, T2 squared. Sorry, squared. See? Very good. And now I can write two situation. Two situation. Then if I have if I have one situation, I don't need to go far away and find k and then I use k to find the other unknown that I have. Okay? So, how about this? The pressure P of a gas varies directly as the temperature T and inversely as the volume V. Okay, pressure P, important, varies directly, temperature T, inversely volume V. Okay, so P alpha T, P alpha 1 over V. I have P, I have alpha alpha, so I do P alpha T over V. Combine them. I combine them. Okay, so I have P equal KT over V. How do you write situation for two situation? Okay, so I have PV equal KT and I have K equal PV over T. Okay, so P1 V1 over T1 is P2 V2 over T2. Remember, when you solve for K, then you are able to find the formula for T situation, and that's very, very helpful. Okay, so now it says, oops, now it says T is 50 Celsius, V is 200 inches cubed, P is 30 Pascal. Find pressure when T is 70 Celsius and V is 300 inches cubed. And all of them, so the units are the same, so perfect. Okay, so T 50, V 200, 30 equal P 2 70, yes, over 3, what's going on? No, it must be, yes, 70 is in the denominator, 70, 300. Okay, find the answer. So find this guy. Okay, so 300, this multiple 50 is 30 multiple this, which is 30 multiple this divided by this. Okay, so P2 is divided by this. Okay, so which is 28. Okay, so 28, what is the unit? 28 psi. Okay, right? So I can just write it. So how do I know? So how do I find it? I need to find two situation formula, and two situation formula is found by solving K. Okay, so how about this one? So I have this question, and I have this question, and I have this one. Okay, so combined. Okay, gas law leading to ideal gas law. Okay, so the force of a moving object varies directly with the product of mass and acceleration. Okay, so this varies directly, product this. Okay, so F alpha ma then means F is kma. If mass remains constant, see here I say mass remains constant. What happened to the force when the acceleration is divided, is cut in half? Okay, so when I say constant, so see I have F equal kma. So acceleration, this is divided by 2, that's constant. So what happened to this one? Okay, so yes, F is also cut in half. Okay, how can I do this using just for example mathematically? Okay, here if you do the line here, this what I did, I accept. So I say okay, so F is kma. So if one of them divide by 2, so the other has to divide by 2, otherwise doesn't make any sense. Okay, so I accept. But if I want to do mathematically, what happened? Okay, so F1 is km1a1, and it is k, just capital K a1. Why? Because m is also remains constant. Okay, so I can just combine them, m and k to another k. Okay, so acceleration, so a2 is a1 divided by 2. What happened to f2? Okay, so f2 is, I start from what I need. I start from F2. I write the original formula. F2 is KA2. Now I substitute for A2, which is KA1 over 2. What is KA1? KA1 is F1. Okay, so F1 divided by 2. Yes, this is mathematically. How about here? If the same object, for the same object, what happened the force when the acceleration is tripled? Okay, if acceleration is multiple 3. Okay, so F is Ka, right? So F1 is Ka1 and acceleration is 3a1. So what happened to F2? F2 is K2a2, sorry, Ka2, which is K3a1, which is 3Ka1, which is 3F1. Yes, that's also tripled. How about assuming the force remains constant? Okay, so now I have F alpha ma, right? Yes. So I have F equal k ma, but F is also constant. Okay, so I have F divided by k equal ma, and then I can say, okay, so this is capital K because both of them are constant, so ma is k. Okay, so I have what happened in acceleration. So if the mass is doubled, what do you think? Here is ma equal k, so here is not direct, is inverse. M and A inverse, because right now I am talking about M and A. Okay, so I do, okay, so I do M1 A1 is K. I do acceleration if the mass is so M2 is 2M1. So I acceleration, so A2 is K over M2, which is K over 2M1, which is uh, A1 over 2. Okay, so mass is doubled, acceleration is divided by 2. Acceleration is cut in half. Okay, so if you want to do it just, this is mathematically, but if you want to do it just with the formula, you can say this. Okay, so K, oops, what happened? K is MA, K is MA, okay? So you would say, okay, K is not changing, so then it is M, what happened to acceleration is the mass is double. Okay, so 2m, so of course I need to have a divided by 2 that I will be able to cancel 2 and 2. So that's why I say it's cut in half. Okay, so a cuts in half. Okay, or is cut in half. So here, okay, so how about this formula? So this and this. So here I stop, that's video number 2, and then I make another video for this example and this example, because both of them are very important. I don't want to make you tired with one video and then the upload will be hard for me. Okay, so I stop here. Thank you so much. Do practice on these things. You can find many questions online, and also you can check the practice part to find the question. Thank you.